Hello and welcome to the second and final part of our transition state search tutorial for the tautomerization of pyrithione. In part 1, we performed a potential energy surface scan to find a good starting geometry to use in our transition state search, and that geometry is in our input window right now. Before you start a transition state search, it is important to do a frequencies calculation prior to confirm the presence of one imaginary vibration frequency indicating the transition state. So we're going to switch our task to a single point followed by a frequencies calculation. We're going to keep all of these settings default, and then we're going to save our file as pyrithione frequencies, save, and we're going to run this job. Super quick, there we go. SCM spectra. We can confirm there's only one vibrational mode with a negative frequency indicating this is imaginary. So then we can close our spectra, and now we can perform our transition state search. So now we can run the transition state calculation. So we go to task, transition state. We will still do a frequencies afterwards. We go to details, geometry optimization, change our initial Hessian to from file, and we will select the frequencies results DFTB.rkf. Now we are ready to run our calculation, so we're going to save again. And we will now name it TS search. Save, run. Okay, there we go. Calculation has finished. And now you can see the transition state. So you can go to spectra again because to see if there's an imaginary frequency. Okay guys, I am back and I figured out what the problem was with my previous calculation, and I forgot something really important. When you launch up the transition state search and you go to the geometry optimization, under the details tab, you choose the Hessian from file, and then you select the frequencies results folder. You select the DFTB file, just like I did previously. But then you can see here, it says constraints, and if you go and explore that, we still have a constraint set up from the energy surface scan. So we want to remove that, and then we can save our file and name it transition state search, save, and then run. We will see that when we read the new coordinates and we then go to SCM and spectra, we have an imaginary frequency right here in our transition state. Now to find out more about the transition state, we can change our task to IRC, which stands for intrinsic reaction coordinate, and we can disable the frequencies calculation, and then you can explore these settings. You can read all of these text balloons. For this tutorial we will just use the default settings, and then we will save our file, save as IRC, save, and run. Okay, that's finished. Now when you go to movie, we have the reaction coordinate right here of the tautomerization with the transition state, which is very characteristic for a pathway where one product is higher in energy than the other one. The transition state tends to lie towards the product of higher energy. Now we can close this and we can look into some more detailed information about this reaction coordinate by going to SCM, output, And at the bottom of the output file, here we go, IRC summary. And that was it for this tutorial. Leave a like if this tutorial was useful for you. Comment down below what tutorial you would like to see next. Subscribe to our YouTube channel for more tutorials like this. And as always, take care.